Hey guys, welcome to chapter 16. This video will serve as a super quick introduction to acids and bases. In subsequent videos, we will dive into much more detail. But just a quick overview of just some general properties of acids and bases before we dive into the chemistry of them. So, properties of acids. Acids tend to have a sour taste. Don't taste any in the lab, please. I'll give you some examples. So some examples would be citric acid. So citric acid would be things in limes, lemons, that sort of thing. Tartaric acid is one of the powders that they put on Sour Patch Kids on the outside of those. So tartaric acid has that sour flavor on those Sour Patch Kids. Okay. Heartburn. So if you've ever had a heartburn before, sometimes people complain of kind of a sour taste in their mouth. That sour taste is from your stomach acid, hydrochloric acid, coming up and reaching some of your taste buds. So again, that's another example of sour taste. Acids are known to dissolve metals. So many cleaning of metals is done with an acid. So it dissolves metals. And then we'll see this in the lab. It will turn blue litmus paper to red. So in the lab, we have two different colors of litmus paper. We have blue litmus and red litmus. Acids, if we dip red litmus into an acid, it just remains red. If we dip a blue litmus paper into an acid, it'll change the color from the blue to a red color. So very often what you'll see is when acids are drawn or denoted in tables, they have a red color, and that's just to drive that home. Bases, on the other hand, bases have a bitter taste. So some of your coffee and dark chocolate, sometimes that's an acquired taste because they do taste a bit bitter. But those are two things that we do eat and or drink on a regular basis that have a bitter taste. For the most part, we don't like a bitter taste. So it's kind of a natural aversion for us as protection. So a lot of things that are not good for us do have a bitter taste. So we're just, we have an aversion to that because we're not supposed to eat it. Bases tend to have a slippery feel. So if you're dealing with bases in the lab and your hands start to kind of feel slippery and slimy, you probably have a base on them. Many soaps or cleaning products, bleach, for example, is a base. And so soaps have that slippery, slimy feel to get things cleaned off, washed off, but that is the base, one of the properties of the base in those soaps. And then bases are often denoted with the color blue. So again, we have red litmus paper, blue litmus paper. If I dip blue litmus paper into a base, it just remains blue. If I dip red litmus paper into a base, it will turn from red to the color blue. So very often bases are denoted with a blue color. So here's some common acids, things that we'll see either just in nature that we talk about, like citric acid, or things that we'll talk about very often in this chapter. So then some things to look at here. Let me get my pointer. Hydrochloric acid, kind of the poster child for acid, metal cleaning, food preparation, stomach acid. Sulfuric acid, so that's another one that we like to use. It's used in many fertilizers and explosives. Nitric acid is fertilizer. Acetic acid is vinegar. So if you smell vinegar at the lab, we're probably dealing with acetic acid. Some things to point out here with the namings. So we see a lot of ic acid, ic acid, ic acid. So these are going to be any of your halogens will end in ic acid. These polyatomics, the ones that have more O's, end in ic acid. If this were H2SO3, so it has one less O, that would be sulfurous acid, or nitrous acid would be HNO2. So just some things to kind of start noticing when it comes to common acids and bases. And then a lot of these too, we want to note the polyatomics here. So up until this point, you've seen these charges on polyatomic ions, and they've kind of been meaningless or arbitrary. Well, now we're going to start to see where they start to have a little bit of a meaning. So for example, sulfuric acid here. So sulfate is SO4 that has a -2 charge. And we see that when it forms an acid, oh, look, it has 2 hydrogens. Or nitric acid, we see NO3 is nitrate here. And it always had a -1 charge. And look, when it forms an acid, it has 1 hydrogen. So hopefully things like that are starting to come together as we start to build our skill set here. So most frequently used, so these are going to be ones that you're going to need to kind of get to know and get comfortable with. We'll certainly use more than just these, but these are some of the poster child for acids. So hydrochloric acid, HCl, you'll see that one a lot. Here we have acetic acid. So here's our acetate ion, so that's C2H3O2 attached to 1 hydrogen. Again, we like to use this one a lot in the lab because it's essentially vinegar. So it's pretty easy to work with. Acetic acid, vinegar, as I said. If you let a bottle of wine sit too long or sit open too long, it starts to go sour. What's happening is that wine is turning from wine into a vinegar. So also you'll see acetic acid, known as sour wine. And then we've got sulfuric acid and nitric acid. As you've seen, both of these are used in explosives, both of them are used in fertilizers. And again, we just see these polyatomics attached to the hydrogen. Okay. All right, so common bases. So one of the common polyatomics to use for bases here is this hydroxide ion. So a group 1 or a group 2 metal attached to hydroxide, that gives us some of our most common bases. There are some bases that don't have the hydroxide ion attached to them, and we'll see how those are still defined as bases with one of our definitions. But again, most of them are attached to this group 1 or group 2 ion. Ammonia is kind of the oddball out. So ammonia is considered a base. There's nothing really about that screams base. But if you can just kind of memorize your way into ammonia being a base, that will be pretty helpful in this chapter, just so when you see it, you recognize it as a base. So that's our introduction to acids and bases. Like I said, just a really brief introduction. In the next few videos, we will dive in much more detail. I hope you guys found this helpful.